Hey guys, Mr. Marone here. Welcome back. Just got a short video here to kind of wrap up our discussion on segments and angles and the basics of that with the idea of congruence. You're going to hear this term a lot throughout geometry. And the idea of congruence is to have the same length or the same measure, something like that, but we're physically talking about the segments. And so the big difference here, if you notice, down below, we've got both segments and we've got angles. And it's this equal sign with a little squiggly above it. And it's discussing segment AB and segment CD. And it's saying that they're the exact same. That if I cut out AB and placed it right on top of CD, that they'd be exactly the same. Same with PQ and RS. Our symbol for that is an equal sign with a squiggly above it. And the big difference, what's different between this and just being equal, is when it comes to segments, we would say segment AB is equal to segment CD. That means that their physical measures are the same. So these, when it's referring to equals, we use numbers. When it's referring to congruence, we use their actual lines. So when it comes to AB equals CD, that's saying the measure of AB, let's say it's 5 units, is the same thing as the measure of CD, which is 5 units. Where we deal with congruence, it's saying that physical segment AB is the same as physical segment CD. It's a slight difference, but it helps us a lot. Now, the beautiful part of this is that these are interchangeable. If I'm told that AB and CD are the same thing, then their measures have to be equal. So they do work back and forth. If I know that AB and CD are both equal to 5 units, then I know that they are congruent, that their segments are exactly the same. With angles, it's a little bit easier to tell the difference because if I'm saying that angle TUV is congruent to angle XYZ, that means the measure of angle TUV is equal to the measure of angle XYZ. Okay, the measures are in front and that gives us that indication. Now, what you want to notice is in my segments here in AB and in CD, they have this red tick mark in the middle. It might not always be red, but there'll be a tick mark. That's indicating that those segments have the same measure, that those segments are congruent. If you've got PQ and RS with 2 tick marks, that means that they're congruent. So any pair or collection of the same number of tick marks indicates that all of those segments or all of those angles are congruent. When it comes to angles, they have small arc marks inside of the angles to indicate congruence. Now, the beautiful thing is it gives us the ability to solve problems like we have here in our 4 examples. So I'm going to step through 1 and 2 with you, and then I'm going to let you guys try 3 and 4. So in example 1, they say, what is the measure of HF? So they want this measure right there. Well, if you notice, HG and GF create HF, segment addition postulate that we just learned. Well, HG has 2 tick marks by it. AH also has 2 tick marks by it, and that tells me it's 11 centimeters. Since AH and HG are congruent, their measures are the same. So we can say that HG is 11 centimeters. The same principle holds with BC having 1 tick mark and GF having 1 tick mark. That tells me that segment GF is 8 centimeters. And using segment addition, I can combine those, and HF equals 19 centimeters. In example 2, they told me that XWZ, the whole angle out here, 127. And they want to know what is angle YWV. So they're looking for this right there. Well, if you look closely, there's a single arc mark here at XWY and a single arc mark here at ZWV. So that tells me I can automatically say that angle ZWV is 32 degrees. Knowing that's the case, the 3 angles that create this outer angle are 32 degrees, x, 32 degrees. We can do x plus 32 plus 32 equals the whole thing, which is 127. Okay, and from there we can solve for x. X plus 64 equals 127, and so x is going to give me 63 degrees. With that being said, take a look at example 3. See if you can solve it. Example 3 is using our picture above, so I'm going to clear it out for us that we have a clean slate here. And they want to know if they told us that this length CD was 11.5 centimeters, and that DE was 5.3 centimeters. And they told us that the whole perimeter, the whole figure, equaled 73.8. What's the measure of GE? They wanted this one here. So go ahead and see if you can figure that out. All right, welcome back in. So as you can tell, I added up all of the sides. I looked around, and 11 centimeters, there were 2 of them, so 11 plus 11. And I knew that all of my single tick marks were 8, so there's 3 of those, 8 plus 8 plus 8. I added CD and DE, 11.5 and 5.3. And the only segment we didn't have was AB, which is the same thing as GE. So once we have it, we're done. So I just made AB Y. I just gave it a placeholder, and together the whole perimeter was 73.8. When I combined everything together, I got 62.8 plus that segment we didn't know. And subtracting out, we got that segment AB equaled 11. Well, since AB and GE both have 3 tick marks, that means that GE is 11. Go ahead and use the same knowledge that you have to see if you can solve example 4. They told us that NOP was 31 degrees, and they told us that NOQ, the whole thing, was 114 degrees. Go ahead and see if you can solve it. Okay, welcome back in. So, knowing that POR and ROQ were the same angle, I put X's for each of those, and I just did angle addition. 114 equals 31 plus X plus X. And simplifying out, I got that each of those X angles are 41.5. ROQ would be one of those angles, so we are done from there. So take a look at the practice problems that go along with this. See if segment and angle addition are starting to make sense, if we're being comfortable. And if you have any questions, feel free to bring them into class when you come in tomorrow. Have a great day, guys. Bye-bye.